Hey, welcome back to another example where we're going to be using the integration by parts formula to solve an integral. So in this case we have the integral of e to the 3x times cos of 2x. This actually has a special format where if you ever see one that is in this form of e to the something x times cos of something x, you're basically going to have to apply the integration by parts formula twice, and this is kind of a special case, and I'll show you why that is. There's a little bit of a trick that we do in the second step, or the second iteration of the integration by parts operation, and you'll see why in just a second. So we're going to be using the integration by parts formula, which is right here, and yeah, let's get started. So we're going to have to define one part of the integrand that we want to derive and another part that we want to integrate. So let's pick this one, let's call this u, and let's call the rest of the equation here, the rest of the integrand, dv. So what we're going to do is we want to derive u and integrate dv. So we're going to start here with just what we have for u. U is just equal to e to the 3x, so du dx, when we take the derivative of this with respect to x, is just equal to 3e to the 3x, and we can just rearrange this to bring the dx over on the other side, or multiply both sides by dx. So we're just going to have du is equal to 3e to the power of 3x dx. We're going to be using this du later in the formula here. We're going to sub it into du right there. So for dv, we can write that as well. We have identified or kind of defined dv to be cos of 2x dx, and we want to take the integral of dv, so that's just going to be the integral of cos of 2x dx, and that's going to give us v, but we need to look up what is the integral of cos of 2x dx. If you don't have it memorized, that's fine. You can just go to an integral table, and I've got one here on the Engineer for Free website. There's a link in the description below if you would like to check it out. But basically, you're probably going to have something very similar to this on your exam, provided to you or available to you when you're trying to solve integrals. So we just need to look for the one that has the form of cos of something x, and that is going to be right here. The integral of cos ax dx is equal to 1 over a sine of ax plus c. So let's bring that back into our worksheet. So we just have it here in red, and we can just substitute 2 for a. So when we write our solution here, it's just 1 over 2 sine of 2x plus c. Now I just read it in red because I'm actually going to drop it from our work for the next few steps. You can keep it in. Technically you should keep it in every single step, but we're going to see here that it's just going to have it's going to give us a whole bunch of terms that include the arbitrary constant multiplied by something else, and it's just going to get really, really messy. And at the end of the problem, all of those terms that are just the arbitrary constant times something else are all going to get combined into one single term for an arbitrary constant, so it doesn't matter actually at all. And it's just going to be way easier to just drop it, as long as you remember at the very end of the problem to put it back in the solution, because if you don't, you're wrong, and you really don't want to forget that. But anyways, in this video, I'm going to drop it, and at the end of the video, I'll remind you that we're putting it back in again. Okay, so let's rewrite our integration by parts formula, which is just here. It's u, the integral of u dv is equal to u times v minus the integral of v du. Now we have all of these components. We have u, it's right here, it's e to the 3x. We have v, it's 1/2 sine of 2x. We have, what else do we have? We have du, we found du right here, it's 3e to the 3x. And dv we originally defined up here as cos of 2x dx. So we can actually plug everything that we have now into this formula. So u dv is also already defined as I, so I'm just going to roll with that for the left side. And that's all equal to u, which was e to the 3x times v, which is 1/2 sine of 2x plus c. But again, we're going to drop that plus c for now just to make our lives way, way easier. And we're going to subtract the integral of v du. So v, again, is 1/2 sine of 2x plus c, but we're dropping the plus c, multiplied by du, which is 3e to the power of 3x dx. Okay, so now at this point, we have done something. We applied the integration by parts formula, and we've got this, but we still have an integral in the solution for I, and basically we're looking for what is I. So we need to deal with this. But if you look at this again, we have two parts that looks like it's going to be an integration by parts style formula. So actually, let's maybe simplify this a little bit. Let's rewrite everything out, and maybe pull out this 3/2 just outside of the integral first to make it a little bit easier for us. And we can even rearrange it just to have it in a more familiar form of e to the 3x times sine of 2x, just reorganizing the order there, dx. So when we have this, we want to apply the integration by parts formula again. It doesn't really matter which one you pick because both can be integrated and derived easily, but if you pick, for example, the exponential to be u here, you should pick it again to be u here. So this is going to be u in our second integration by parts iteration, and this is going to be dv. So let's maybe bring our work right up into this space and run through iteration number 2. So in this time, we're saying that u is, well, it's equal to e to the power of 3x. So we have du dx, the derivative of that is just going to be equal to, again, 3e to the 3x, and du, again, for this iteration, is going to be 3e to the 3x dx. For dv, again, this time we're going to have sine of 2x dx. So we're going to take the integral of that, dv equals sine of 2x dx, and for this one we can check the integral table, and when we see here we have the integral of sine of ax dx equals 1 over a cos of ax plus c. So for us that's going to be v on the left hand side, and on the right hand side that's going to be negative 1/2 cos of 2x. Again, this is plus c, but we're just going to drop it for now because, again, already we would have a whole bunch of terms that are plus c, and it's just going to keep getting more and more and more, and we just don't want to deal with those. So now we want to, again, use the integration by parts formula, so let's write it out again. This is u dv is equal to uv minus the integral of v du. And the integral of u dv is this thing, okay? We have u and we have dv. So this whole thing is equal to this stuff. So basically we're replacing negative 3/2 times the integral of u dv. We're just going to swap out the u dv part and we're going to put in this stuff. So we can just write it down below. This is just going to be equal to 3/2 times u, which we identified as e to the 3x, times v, which is negative 1/2 cos of 2x. Again, not using that plus c. And then we're going to subtract the integral of v du. So this is going to be negative 1/2 cos of 2x. Again, not including the plus c here. And we need to multiply this by du, which is 3e to 3x dx. Alright, let's just rearrange this a little bit just to make it a little bit easier to look at. So this is 3/2 times negative 1/2 e to the 3x cos of 2x. Then it will be plus, we can pull out this 3 and this half, and that negative turns the negative into a positive. So it's going to be plus 3/2 times the remaining integral, which is e to the 3x times cos of 2x dx. Now at this point it's really important to recognize that this right here, the integral of e to the 3x cos of 2x dx, is exactly equal to I. This is exactly the same thing, e to the 3x cos of 2x dx. So this whole thing is just equal to I. We can really substitute this in just like that. This is equal to I, and we're going to have to use this to simplify the problem. So let's continue what we had here, where we had I is equal to 1/2 e to the 3x sine of 2x. And then it was minus, and it was minus all this stuff. And all this stuff is all this stuff as well. Okay, guys? So this is going to be minus 3/2 all times negative 1/2 e to the 3x cos of 2x plus 3/2 times I. If you didn't recognize that this is equal to I, you're just going to go in circles all day long, integrating and integrating and integrating, and you're never going to get anywhere. But when you realize that this is equal to I, this I actually now we can bring over to the other side and simplify some things. So let's actually make some more space for ourselves and keep going. So again, the first term here is not changing. This is 1 over 2 e to the 3x sine of 2x. We want to distribute out this 3/2. So when we multiply it to the first term, we're just going to get plus 3 over 4 e to the 3x cos of 2x. And then when we distribute it to the next term, we're going to get negative 9 over 4 times I. Okay, at this point we want to add 9 over 4 I to both sides. So here we have 4 over 4i, it's just 1i. So 4 over 4i plus 9 over 4i is going to be equal to 13 over 4i just like that. And then we're just left with everything else that we already had. Now at this point, we should just multiply both sides by 4 and then divide both sides by 13. So we're just going to be left with I is equal to 4 over 13 times the whole right-hand side. Now there's just a few steps left until we get it in its most simple form, but we can pretty much just distribute that 4 into each term, I think, is the next step we should take. So we're just going to have 1 over 13, and we're going to distribute that 4 in, so that'll actually be 2e to the 3x sine of 2x, plus 4 over 4 is 1, so this will be 3e to the 3x times cos of 2x. And then what we can do is actually we can pull out e to the 3x because that's in both terms. So we'll just get I is equal to 1 over 13 e to the 3x all times 2 sine of 2x plus 3 cos of 2x. And this is actually the most simple form that we can get, and at this point you absolutely have to remember to add in the plus c, or if you carried it through the whole problem, you're going to see that all of those like 10 terms that you have now with plus c are all going to combine into one, but just absolutely do not forget to add in that plus c. And guys, this is the solution to our original problem when we were asked up here to take a look at what is the solution of the integral of e to the 3x cos of 2x dx. So yeah, hopefully that helps. If you ever do see a problem with this form of an exponential times a trig function, you're definitely going to be looking at integration by parts 2 times using the special condition here where eventually on the second iteration you're going to, the integral will turn back into the original integrand, and then you're going to use that throughout the problem to continue solving until you get the solution. So guys, thanks a lot for watching, and I will see you in the next integration by parts example.